Welcome to the second episode of installing NMS Prime on Red Hat Enterprise Linux version 9 or Rocky 9. In the last episode we installed Rocky 9 with NMS Prime with all the open source modules and also the Prime modules. Once we've done this, we end up with a web GUI, as you can see here. We are on localhost 88 right now. We are basically tunneling this through SSH, but of course you could also use the IP address of your VM, and then on port 80 you will see the login screen. We do have a default login. The username is root. The password is the opposite, is TOOR. In this case, you can see I can log in. I can see that I should probably change my password. I'm not going to do this now, but this is the first view you can see. You see it's threefold. First we have our top page, or our top line here, where you can search basically through anything in our database. You can also search for an IP address of any device and find the corresponding IP device. And you can also see here my user, which is super user initial. You can see my own settings with my first name, last name, my email address, and the role I am in. And you can also see all the users. If you are, for example, an admin, then you'll be able to see the other users. In this case, we have another one which is for internal webhook. And of course, since I told you about the roles, you can see here the roles which are automatically set up during install. There's obviously the admin role, which cannot be deleted. This is allowed to do anything, so we have a custom ability to allow everything, and then based on this you can forbid certain things. But of course also you can do it the other way around, that you say, for example, the guest is not allowed to do anything, and then you can allow certain things. And in this way you can very fine-grained determine what the user can see, delete, create, update. For example, here in the provisioning case, it's not allowed to do any provisioning, but if we go, for example, to our support role, which is here, you can see, the support is also allowed to do anything, and then you can forbid certain things. Anyway, going back to our NMS Prime page, you can see on the left hand all the apps which are installed. These are our native ones, the NMS Prime apps, and then down below you have the external apps, some open source tools which we are using and which we also expose to you. Clicking here on the native apps, you can see all the apps which are installed, also the external ones, and you can also search for new apps which are in our repository but have not been installed yet. Okay, so if we go back to NMS Prime, to our main page, you can see we do not have any modems right now, so we don't have this donut view, but we have one net element, which is basically the VM itself, so we are also monitoring ourselves and all the services which are provided by this VM. So you can see down below here on our trouble dashboard, you see some services have critical and warnings, and some are unknown. And here we have, for example, an issue with the updates. We see that there are some services disabled, for example, the Junior ACS stuff, which you don't need at this point in time, since we only talk about in this episode about DocSys provisioning, so we don't need Junior ACS. But for example, also the radios is not running, but we also don't need it as of now. And also the updates have not been running. And furthermore, we enabled the debug mode for our testing purposes. Okay, so since we are talking about provisioning here, we first have to start with a global configuration. So we go to the global config page, and here you can see, first off, you may want to set your ISP name. So let's say we have NMS Prime as our ISP name. The street is here, Elisenstraße 32. City is Chemnitz. Phone number we don't need. Let's say we have an info@nmsprime.com. And that's about it. So let's save it. Then we could also look at the provisioning up here. For example, what's not correct right now is the IP address of ourselves. This is another VM in our network, but the provisioning server IP here is the .3. You can set the read-only and write community for SNMP, which will be then pushed onto the modems. Since this is a test system, we remain with public and private, and then you have the domain name below which all the modems are located, and of course DHCP, the default and max lease time, and the password for DNS. But this is all automatically set up during installation, so we don't need to do anything about it. Since we changed this up here, of course we need to save. And then we could check also monitoring, but in this case, which is also kind of interesting from this tutorial, but in this case we can also just leave everything as is. Okay, now for provisioning, of course we first need to set up a contract. In this case we already have 2 contracts, but we don't want to use them, we want to use another one. So let's create one here, and let's say with the contract number 1. You could theoretically, if you have from older systems, or if you're migrating from a different vendor, you can of course use some legacy contract or customer numbers if needed. In this case we don't need it. We have a salutation, in this case a German one. Of course in the US market or wherever you are, we would change the salutations accordingly. This is basically just a file where we put all the salutations in. In this case the first name is NMS, last name is Prime. This street name is again Liesenstraße 32, like this. Postcode is 09111. City Chemnitz. Country code you can set if you want to. We don't need a phone number. Maybe the email address would be good, info@nmsprime.com. The birthday, let's say, is 1st 1970. And the contract start can be today, for example. We want it to be invoiced, this customer, and we want to have it in a certain cost center. So if you have different banking accounts, where some contracts should be invoiced via this banking account and some via another one, you can do this via the cost center. We save it. Has been created, as you can see, and now we can create a new modem in it. So let's go to plus modems. You can see we can already choose a config file. In this case we can use the base one, and you may ask where is this coming from. This is one we provide during installation. So if I click here on the config file, you can see we have one for the MTA, one for the DOCSIS modems, and one for ONTs or ONUs. So let's go to the base DOCSIS file, and you can see, you probably know this, how the structure looks like. You can see we can use variables here. So we will take the QoS from the contract, and then we'll replace this variable with this actual value. And you can also calculate with it. For example, here we do it times 0.1875, so basically 18% roundabout of this rate will be our max traffic burst. So you don't need to adjust this for every different quality of service or class of service. We will replace it accordingly. We want to enable probably global privacy, and then the rest is some firewall filtering, and here you can see the SNMP monitoring stuff. You see we want only the provisioning server to be able to both read and write to the modems. And again, we are using variables here which are coming from our global config. So if you remember, we set up here the provisioning server IP. So this IP will then be replaced here, and the community is basically these two options here. So we can save it, and now we can use it. So we have chosen the base config file. We can call it test modem. Now we need a MAC address, obviously. We can look at this via our CMTS. Show cable modem. Let's say we're going to use maybe this one. Put it in here. As you can see, we have multiple formats which are allowed. Colons with dots or with nothing in between. And we will filter hexadecimal characters, we will filter out. Serial number we don't need. This would be for CWMP, for TR69, which we don't use. We want internet access, obviously, for the modem. We have a QoS already set up, and that's basically it. You can see we are automatically taking all the metrics and all the parameters from the contract. Of course, you can change this if the installation address of your modem does not correspond to where the contract will be sent to, or the invoices will be sent to. You can see we do not have any longitude latitude here, but if I go to save now, you will see that this has been automatically set up, and this is possible because before the screencast, what I did was I went to etc NMS Prime and global, or actually, this is still in the cached version. So what I would need to do would be I go here to OSM, nominatim email. So basically I will have to set up an email address, in this case info@nmsprime.com. I can also add, if I have, a Google API key or a Here Maps API key. For this I would need to create an account and put a credit card into it, and then I have a certain free budget of requests I can do every month. But for now, we always use OSM, OpenStreetMap first, then we go to Here Maps, and then last but not least also Google Maps. And if I do so, then I would have to do the caching. So I'll do PHP www NMS Prime artisan, and then I do config cache, which I did before, and that's why it worked without having set the email address. So if I do this now, then I can, basically, OSM will do this in the background for me. Now I can click on the geo position here, and you can see that now the modem is probably placed on the map. What I can do now in parallel is I may also add an MTA, right? So currently I only have the modem. If I want to have telephony, I can set up MTAs. So I click here on MTA. You see automatically, if I go back to the modem ends with 6.2, and now normally the MTA is just one above the MAC address of the modem, so we automatically do this here. I don't need to set a host name. It will be automatically chosen, and then I just choose the base MTA which we set up, and now this one is set up as well. We are now trying to restart the modem. Since we do not have any connections with the CMTS now, it tells me, okay, I can't reboot neither MTA nor modem because I haven't seen the modem yet. So this is to be expected. And then of course I can set up a phone number. I can say I want this in port 1. International prefix should be 0, or I think it's 49 just. Then maybe, I don't know, maybe 351, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, or something like this. User maybe is user, password is secret, so this would be the zip, maybe let's call it zip user. This would be the zip credentials and zip secret. My registrar is zip maybe .nmsprime.com, and I want this to be active. Now if I save and restart, you see it's set up properly, and now we can check the corresponding config files. Okay, next up, of course, we need to set up CMTSs. So for this, we go to provisioning and net gateway down below here. And the net gateway could be either a CMTS, could be a BNG, could be an OLT. So we subsumize this or summarize this as net gateways. So let's go to creating one. In this case, we have a Cisco UBR 7225, which is a CMTS, obviously. I call it dev cable, as you can see here, I called it dev cable gateway 01. So let's go with this name. The IP address is, I believe, let me have a look. IP address is this one, 3.250. I don't need private or public community strings because I just want to use them which are on the global config. So I can leave it. Now I save it, and we have our CMTS. Okay, next up, and you can see it's pingable, so that's fine. Next up, we want to add some IP pools. So first off, we have one for the cable modem. We can look here. If I do show running config interface bundle 1, you can see the IP addresses which we set up in our bundle. So we want one, the primary one for the modems, is in the 10 range. So this is a /19, and so we can just leave it as is. We don't need any DNS servers because the cable modems do not do any DNS. So let's save it. Then and you can see it's pingable. Then we add one for the private CPEs. So CPEs with private IP addresses. It's in the CGNAT range /22, which, as you can see, is basically this one. And the router or the gateway is 3.254, which you can see here. We give it one default DNS entry. Of course, you can set up other DNS servers if you're so inclined. So let's say these ones. I'm going to save. Again, it's pingable. That's good. And last but not least, we can also set up an MTA pool. In this case, I don't want to have it /22, but also 24, but /22 as well. I can calculate this if I want to, if I don't know for sure. So it starts 01 to 3255. So this is, I have to change this. So this should be all three here. And you can see the DNS server is set correctly. This is our own provisioning server because we need to resolve, for example, the SIP registrar and also some other DNS addresses. So that's why you should set this to the provisioning server here. We can save it. It's pingable again, so everything looks fine so far. And now what we can do is we have now basically everything set up to be able to provision the modems. Of course, we need to go to the CMTS and set the cable helper accordingly. But what we can also do in parallel is that we can add kind of this logical view, or how NMS Prime perceives it, and the user. We can help with troubleshooting, and for this we will add some networks, some clusters, the CMTS, and some modem positioning rules. So for this, we go back to our modem, click on this modem here. Currently, of course, it's shown in red because it's not online right now. So if we go here and we go here down below to our longitude latitude, you can see where the modem is located. What I will do now is I will add a new net element. So I'll go position a device and maybe I'll put it here. So this is where my network is. So I can say create net element. You can see we automatically set up the longitude and latitude. And now I say this should be network. I call this network chemnets. I don't need an IP address because this is a logical device. I don't need a community whatsoever because, as I said, it's just a logical device. And I don't have a parent because this is my top element. Now I can just save. And I'm going to copy these coordinates here because I want to have it on the exact same position. I'm going to add now CMTS. So let's go and click. You can see the network is now here. You can also see it's down below here, chemnets, with nothing inside right now. So I'm going to add a CMTS now. So let's have a look and say I want this, or maybe net gateway like this. Name should be this one. IP address should be, I can choose it from my net gateway. Just say net gateway was, I believe, this one. No, wait a minute. Yeah, this one. So let's go and put it here. IP address, provisioning device. We don't need as of now. The parent. Wait a minute. Here we go. Right. Parent is chemnets. Provisioning device is our dev cable gateway 01. The IP address is this. No, wait a minute. This is the name. The IP address is down below here. The name was this. Here we could use the read-only and read-write community, but again, if we don't set it, we use the one from the global config. And now I copied the longitude and latitude. I'm going to put this here. Now if I save, I have the CMTS. And now I also want to add a cluster. So let's go here. Let's say it should be a cluster. I call it Chemnitz cluster. I don't need an IP address, I don't need any communities. The parent should be the net gateway. Longitude and latitude I set again to the same coordinates. And now you see down below we have our cluster, we have our network, and if I click on it, you see the network, then the CMTS, and then the CMTS is basically building a cluster. What I can do now is I can go to the net topology, and here you can see basically, right, the network, you can see the device, and the modem was here as well. And now if I want to add a rule to place the modems behind a certain net element, in this case behind my cluster, I can use the polygon tool, as you can see here. So I'm going to draw a polygon here, which shows a certain, or uses a certain number of houses here in my location, and basically everything inside this polygon now, I will assign this as a new modem positioning rule to the net element Chemnitz cluster. I call this rule Chemnitz cluster as well. I mean, I can call it Chemnitz cluster MPR with a positioning rule. You can see all the vertices up here. So if I save now, this polygon is being saved. You have all the vertices here. Now if I go to the net topology again of my cluster, for example, I go to net topology. You can see now the shape of the polygon. And if I now click, for example, if I go to ERD, you see there's this one modem, because now it's within this shape. I draw the shape like this, right? And the modem is inside. So now I assign this to the cluster. I can of course show also the whole network. Now I have my network where the CMTS is located, which is creating one cluster, and within this cluster we have this modem. And now I have a good view to see maybe a certain cluster is down, maybe the whole net gateway is down. And based on this I can see it directly here, or of course I can also see it on the map, maybe, or if I go to the modem topology, maybe I can see, okay, maybe only this one is down and the rest is up. Then this is a local issue. If all the modems in this vicinity are red, then I know it's probably an issue with the CMTS or with the configuration or whatnot. So the last thing I would like to show you now is what changes were done in the background when we added something via the graphical user interface. So of course, when we add a contract, what's going to happen is basically adding a new line into our database. But when it comes to the modem, of course, there will be more changes happening. First off, when I create such a modem, if I go to etc DHCP-NMS prime, you see certain files here. The modems, if I add a modem, they will be added here to my modem host config. You can see now here we have one modem with the MAC address we set up before, 62, with a file name. It's cable modem / cable modem dash the ID of the modem, as you can see up here, and then with a dynamic DNS host name. And also this is for the MTA. If you create an MTA, we set this DHCP server such that the modem will go online, the MTA will go online, or actually try to go online. Yeah. And for the MTAs, you will see we have an MTA conf here. So if I click on this one, it stops with 63. 63 you can see here. MTA-MTA1. This is the MTA ID, and the host name is just one. So you see we have one config file in the CM directory and one in the MTA directory. And you will see them as well if I go to TFTP boot and then CM. You can see here we always have dummy and then we have our actual cable modem file. So you can have a look at it with less, and you can see now all the variables have been replaced. If you remember, if we go back to the config file, I told you that in the base we have here our variables, and now you can see the variables have been replaced. Also down below here, prof-based provisioning server, prof-based community, you can see it's all there. And based on this clear text file, we now also have a binary file. So if I do this, you see it's a binary file. Well, some file. This is obviously not correct. I can also docsys decode this with my docsys tool. I can go there, do this, and then I basically get the same like the clear code, clear text file. The same is happening for the MTA. So if I go into my MTA folder, you see there's also one with MTA conf, MTA.1 conf. So let's go here, and you see in this case it's very simple because I was just using the base MTA config file, which doesn't contain much at all, basically nothing, because the MTA config files are always specific to the different vendors. And if you want to have a suggestion how you can create such an MTA, you can always go to demo.nmsprime.com, and there you will get some suggestion here in my config files. Wait a minute, not dev, but demo.nmsprime.com. I can log in as customer, and then you have many different examples here. And for example, here for the MTAs, or let's say here, you have one for Fritzbox, for Ares, for Cisco, and so on. And there you can basically just copy paste it, and then you can get your MTAs running as well. So the demo system is always available for you, so you can check it out yourself. And you saw the login, it's customer for the English login. Okay, so we have the TFTP set up. Then obviously, if we go back to our DHCP server in -DHCP, etc/DHCP-NMS prime, you see we have some more files. For example, when I was adding the CMTS as a NAT gateway here, you see that we automatically put in our CMTS gateways that we should load the 4.conf. And if I go to this file, you see that here are my pools basically. So I added an IP pool for the cable modems in the 10 range. This is what you can see here. Then I added one for the private CPEs. So this is only for members of cable modem. Then we have for the private CPEs for devices of type client and not client public. And last but not least, we also have one for MTAs. I set my modem to be a one which is not public, so the CPE should not receive a public IP address. And that's why you can see if I go into my file modems clients public conf, you see there's nothing in here. On the other hand, if I were to go to my modem and change it such that the CPE behind the modem should get a public IP address, so if I hit this and save it, then you will see, of course, this error message is as to be expected because we did not see the modem yet, because we have not configured the CMTS in a way, or we didn't change the cable helper basically to talk with us, and so we don't know the modem, so we can't resolve this hostname, and so we can't determine behind which CMTS the modem is, and so we can't talk with the correct CMTS to restart the modem. But this, of course, will resolve itself once the modem goes online for the first time. But now I added this public flag here, and now you will see that here now the modem is added. So from now on, the CPEs behind the modem will get a public IP address. Another thing which we can do is we can set up endpoints, and the endpoints we use for setting static IP addresses. So at this point in time, if we go to endpoints, you see there's nothing inside the file right now. But if I go here and say, maybe, let's look, well, at first, let's just say I want my private IP addresses back. So I remove this flag. Now you see the file is empty. And now let's say I want a certain IP to be assigned to the CPE. So if you remember, we have certain IP pools for the private CPEs. And maybe I want my endpoint to have a fixed IP address, and I want this maybe 0.1 or let's say 0.42. And I could also set up a reverse DNS record if I want to. Of course, only if you set it up properly, that our provisioning server will act as a name server for the corresponding domain or zone as such. So now I can save it without, for example, I can do this without specifying a MAC address. So if I save now, you will see, of course, we started to retry to restart the modem again. Didn't work, obviously, because the modem is offline from our point of view. So if I now go to the endpoints, you will see we have one, and here we say whenever we see a CPE which is behind this modem with 62, we will always hand out this IP address. Of course, this means that if you have multiple CPEs behind this one modem, always the latest or the last one doing the DHCP request will get this IP address. What you can also do if you have multiple CPEs behind one device, you can say, okay, maybe I have one CPE, maybe I have a bridge modem with a CPE behind, and maybe the CPE has the following MAC address. Now I can save it. And now if I look at this file again, you now see I'm not referring to the remote agent anymore, but now I'm referring to a MAC address. Now I always say a CPE with this MAC address will always get this IP address. And the last interesting bit I wanted to show you for debugging purposes is our firewall. So internally we are using the firewall D to implement a firewall, and there is a command called firewall command -cmd. Then you can do list all zones, and there you can basically see how the firewall is set up, as you can see here. So here you can see all the zones. Of course, you can also see zones which are not active. So I have another command which is a little bit more complicated, but this is the command basically. And now it just filters the zones which are active. And here you can see, so we have one for the cable modems in the 10/19. They are allowed to do DHCP, HTTP, this is for firmware download, TFTP for config file download and firmware download, and 37/UDP, which is the time of day. Then we have our CPEs, which can do DNS, which can do DHCP v6, they can do CWMP provisioning, so TR69 on, this is for the normal CWMP, and this would be for file downloads. Then we have our MTAs in this range. They can do both DNS and TFTP. And we have some NMS Prime internal stuff. Here we can do SSH, TFTP radios and so on, and some public stuff as well. For example, currently we can do SSH, HTTPS and 8080 and some more, as you can see on all the interfaces. Of course, you can adjust this according to your needs, but just in case you run into issues, it might be that this is due to the firewall blocking some requests if you change our default IP address ranges to something else. One more thing as well for the name D for our DNS server, which is located in etc DHCP, name D-NMS Prime. Here we also have some access control lists for cable modems, CPEs, MTAs. So if you, as I said, if you change the ranges, you may want to change this here as well, because otherwise the name D won't answer your requests. And maybe last but not least, when it comes to NTP. We also have our own NTP server built in, which is Crony. If you go here for Crony D and then nmsprime.conf, you see we only have this IP address is allowed, or this range, to do NTP requests. If you want the devices from somewhere else to query this as well, you want to add this here and then restart Crony D. So these are the typical issues we see. For example, here we have, so in our firewall we said NTP is allowed, but you have to do this in Crony as well. Yeah, because otherwise the client or the server won't answer it. The firewall will let it through, but the server won't answer, and so you have to change it in both ends. So these are the typical issues we see. And once you're done with adjusting your firewall, you can do firewall command -- reload, and then it will reapply all the rules, and then you can test again. So this is all for this episode. Next time I will, or actually what I can still do right now is I will go to the bundle interface. So I will do conft interface bundle 1. Now you can see currently my helper is 172.20.01, but my new VM is at 0.3. So I will do no cable helper address and so on, and now I will add one to 3. And so the next step now will be to look at the provisioning, how the modems are coming online, and then to look at the monitoring, how we are retrieving the metrics, how we display them, how we show them over time, and this will be for the next episode. So for now, thank you for your attention, and we will pick up here the next time.